I know you're covering home and transfers right now, but when you're in the manned space business, unmanned satellite's a whole separate thing. You've got propellant that needs to last for the life of the satellite, 20 years. But in the manned space game, time becomes a very powerful constraint because you have a crew up there in one of the satellites that needs to survive, has a certain amount of oxygen, has a certain amount of food, water, propellant, those kinds of things. So we're not real interested in the manned space business and home and transfers. We are interested in what we call high-energy orbital transfers. The mission itself consists of many, many elements, of which just a small portion in terms of your training load comprise on-orbit operations, and then out of all the on-orbit operations that we have, there's only a portion of that that's devoted to rendezvous. So y'all have got a real challenge if you're going to have a successful, if you're going to manage a successful rendezvous in a manned vehicle. You're going to be dealing with a flight crew that's not at the top of their game. Not only are they not at the top of their game physically, you ever seen what a pig looks like when he's staring at a wristwatch? That's kind of like the feeling I had on day 2, staring at this checklist. There's something we call, anecdotally, you're probably not going to find this in any books, that astronauts refer to as space stupidity. As soon as you get to space, 20 points at least go off your IQ, and they stay off until you've been in space for about 30 days. Now, this is a little piece of genius that occurred back during the Gemini program, and as you all know, Gemini was essentially a technology demonstrator for Apollo. There were 3 basic things Gemini had to demonstrate could be done safely and expeditiously before you could even launch the first Apollo capsule. One was EVA, one was long-duration space flight by their standards, and the third one was rendezvous. And they had to figure out, how do you take these Gemini pilots and give them a conceptual understanding of rendezvous? If you have a velocity component along the x-axis, this tells you that if your x dot is positive, you're eventually going to drift up because of that negative sign. If your x dot is negative compared to the target, you're eventually going to drift down. If you've ever seen the movie Gravity,